Hi everyone, my name is Bappi Hamed and welcome to my Generative AI series. So guys, in the last video, we saw the complete introduction about our vector database. There we saw how vector database works and all. Even we also saw why we have to use the vector database, what is the importance of the vector database. Okay. Now in this video, actually, we'll start with one practical demo. That means we'll be learning one amazing vector database, local vector database called Chromadb. You can see Chromadb is a local vector database. So they're also bringing the hosted version of the Chromadb. So you can see it is still under development. So once it is done, you will be also able to, let's say, use this Chromadb in the cloud server as well. So as of now, if you want to store your, let's say, embeddings in the local, okay, that means if you want to set up everything in the local, you can use Chromadb vector database for this. So this is the documentation of Chromadb, guys. You can see this is the official documentation. So they have given each and every guideline. So you can follow this documentation, like how we can set up and all. Okay. So what I will show you guys, I will show you one complete practical. That means we'll be experimenting this Chromadb on the Colab notebook. Okay. So guys, let's open up my Colab notebook and let's see how we can use this Chromadb vector database. So guys, as you can see, my notebook is connected. Now, if you want to test it, whether it's working or not, just write one message here. So I'll just write print. Okay. So it should, yeah. So it's working fine. Okay. So now the first thing, I'll be installing some of the like required packages. Like I need to install the Chromadb and all. So there is the guide actually. They have given like you need to use pip to install the Chromadb and how to like set the client and all, everything they have given. Okay. So first of all, what I will do, I will just set up this Chromadb. So to set up the Chromadb, you will need some more required package. Okay. Some more dependency. I'll tell you like what are things you need. So just write pip -q install. First of all, I need something called Chromadb. So I'll copy the name from here. Chromadb. Then I need something called OpenAI, because I'm going to use OpenAI embeddings and OpenAI, like you can say LM model. Okay, that means GPT 3.5 turbo model. So that's why I need OpenAI. And I also need something called LangChain, because I told you I'll be using LangChain here. LangChain, and there is another dependency you need, something called tick token. Okay, tick token. So if you are using OpenAI embedding, so you need this package actually, tick token. Now, yeah, I think these are the things actually I need. Now let me install it. And guys, you need OpenAI account for this video actually. So just try to create an account here. Otherwise, you won't be able to do it because you need the OpenAI API key, okay, to run this, like you can say notebook. So guys, installation is done. Now, if you want to see, let's say any version of any package, so what you can do, let's say I want to see the Chromadb version. So I'll just copy the name, and here you can just write pip show. Pip show, and just give the name of the package. Now if you execute, it will show you the version and every information about this package. See guys, name is Chromadb and this is the specific version, and this is the entire summary of your like Chromadb package. Okay, so that's how you can see for all the packages, okay, you have installed. Now here, first of all, I need to download some data. Because here I'm showing you vector database example, and there actually I need the data, okay, to show you like how to store and all. So for this actually what I will do, so there is a actually this Dropbox links, actually you can see this is the Dropbox links, and inside that actually you have some article data. If you see, Google article is there, then you have some AI startup article, Amazon article, then you have Databricks article, ChatGPT article. So we have different articles here, okay, and this is a TXT data, TXT format data. Now if I open any kinds of TXT file, see this is the article related to this default, okay, generative AI. So they have written all the article and all, okay. So I'll be using these kinds of data. You can use any kinds of data, it's up to you, but this is the open source data actually I got from the internet, and this is the link of the data. So to download this data, first of all I will copy this link, and here I'll be using something called wget to download this data. So I'll just write wget. So wget is a Linux command, and here we are using Google Colab, and Google Colab is running on the Linux operating system. Okay, so it is running on the Linux kernel. So that's why you can execute any kinds of Linux command here. So here I'll just write wget -q, and here I'll just paste this link. Okay, I'll paste this entire link. Now once it will download, let me show you how it will download. So if I execute this cell, left hand side you will see it will download that zip file. Okay, see new article.zip file, this zip file has been downloaded. Now I also need to unzip this zip file, so I'll just write unzip -q, and this is the name. I'll just copy the name. Mhm. I'll just copy the name, and here I'll just tell the directory like where you need to unzip it. So I'll give the same name. So this is the name, new underscore articles. Okay, so it will create one folder, new underscore articles, and inside that it will unzip everything. Okay, now if I show you, it's done. Now if I refresh the page, I think inside new articles, now see guys, all the articles are present. Okay, now let's see, if you want to open it, you can also open and see. So this is the article and all about. So now let me close this thing. So we have successfully downloaded our data. Now what I need to do, I need to first of all create one OpenAI API key, and I'll be setting up my environment. Okay, so for this, actually what I need to do, I'll first of all open up my OpenAI account. So you just also open up your OpenAI account. Just search like openai.com, and here just try to log in with your account. So let me quickly log in with my account. So guys, as you can see, this is my account. Now here I'll just click on this personal, my this is my profile. I'll click here, and here you will get one option called view API keys. Okay, now I'll click here, and here you will see API keys option. Okay, now see, previously I created some of the API keys, that's why you can see here, but for you it might be completely empty. It's completely fine. So you'll get one option called create a new secret key. Okay, just click here and just give the name. So in this case I'm using vector db. So vector db, I'll just name it. Okay, you can give any name. I'm just giving vector db and create the keys. Now you need to solve one puzzle here. It will verify whether it's whether you are a human or not. Okay, so I'll just click here. Now it's telling just try to move this object with respect to this hand direction. So let me move it and submit. I think yeah, attempt is complete. Now I will get my secret key. Yeah, now I'll copy this key, and here I'll paste it. Okay, as of now I'll paste it, and I'll just give a comment here, setting up setting up environment. And don't share this key with anyone guys, otherwise they will also able to access your like you can say OpenAI account. I will be removing these keys after this recording, so that's why I'm showing. Now here first of all I will import operating system package called OS, and here I'll set the environment. So I'll just write os dot environment environ. Okay, and here you just need to give the keys like which name you need to save it. So I'll just give OpenAI underscore API underscore key, and equal to, I'll set my API key here. So this is my API key. I'll copy, or I'll cut it, and here I'll set it. Yeah, that's it. Okay, now I can remove this cell. Now let me execute. Done. Now I need to import some of the necessary libraries. So import. So first of all I need to import something called Chroma. Okay, so if you're using LangChain, so LangChain already has this Chroma API, because I already told you the integration. So it is the integration with the LangChain as well as the llama index. So instead of like importing directly, like import Chroma, okay, import Chroma, we have to import it like from the LangChain itself, because here I'm going to use LangChain framework, okay, to build my application. That's why I need to call it from the LangChain. But let's say if you're using it for any other like task purpose, let's say you are not creating any generative AI application, let's say you are doing some different thing, okay, different application, at that time you can directly import it, and all the functionality will remain same only, all the code will remain same only, you just need to change the import, okay, at that time. So here I'll be using LangChain. So I need to import it from the LangChain itself. So how to import it? So just write from LangChain dot vector store. So there is a function you will get called vector stores import. So I'll import my Chroma. So I'll just write Chroma. Then I also need to import uh, OpenAI embedding, because I think you remember. Let me open my board. I think you remember, first of all, what I need to do. Let's say I have my unstructured data. So let's say this is my data. So the first place what I need to do, I need to use something called embedding model. Embedding model. So this model might be anything. So in this case, I'm going to use OpenAI embedding model. OpenAI embedding model I'll be using. So you can use any model here. Okay. Then after that, it will return me my vector embedding. Vector embeddings. Okay. And that vector embeddings I will store inside my vector database. Okay. Vector DB. So in this case, I will be using something called Chromadb. Okay, so this is the complete idea. So first of all, I need to import this embedding model as well. So here I'm going to use OpenAI embedding, so I can directly import OpenAI embedding. So let me do it. So here I'll just write from LangChain dot embeddings import OpenAI embeddings. OpenAI embeddings. Okay. Then I also need to import OpenAI, because I'm going to use OpenAI large language model. So again, I'll just write from LangChain dot LLMs, that means large language model. I need OpenAI. Then I need to load my data. As you can see, this is my data and it is present inside a directory. Okay. And again, this data format is a TXT data. Okay. If you see, it's a TXT data. So for this, I again need two libraries. So I'll just write from LangChain. So guys, I'm expecting you are already familiar with this LangChain, because if you check our YouTube channel, so we have already covered this LangChain tutorial and all. Okay. So you can go with that tutorial and you can learn the LangChain. So here from LangChain, there is a class called document loader. So just write document loaders. Okay. So first of all, I'll be import something called directory loader. Okay. Directory loader, because my data set is present inside the directory. That's why I need this directory loader. Then I also need to load my text loader, because it's a TXT data, right? So I'll import the same thing only. Sorry, it should be data loader, I think. Document loader. It's a document loader. Okay. Now it should be text loader. Okay. Yes. So as of now, I need, these are the libraries, and if I need anything, I will be importing later on. So let me just quickly import them. Now we'll be loading the documents. So load data. So guys, to load the data, just write directory loader, and inside that you just need to mention the directory. So here, this is the directory. I'll just copy the name, copy path, and I can give it here. So this is the directory, and inside that actually I have txt data. Okay, I have, if you see, I have txt data. So I only want to load the txt file. So if I, let's say I have some any other file, okay, I will be ignoring. So for this, there is a parameter you can give called globe. Okay, just write globe equal to, so it should be txt file. So all the file just load. Star means all the file. Okay, it should be dot txt. Then you also need to define the loader class. Okay, so just write loader class, and it should be my text loader, because all the file are txt format. Okay, that's why you need to give this text loader. Okay, now it will load up your data, and I'll be storing this data inside a variable called loaded. So this is my object of my data loaded. Now let me execute it. Now to load the data, you need to call one function called loaded.load. Okay, if you call this function, it will load the data, and this data will store it in a variable called document. Okay, and see guys, it will load all the data inside this document. See guys, this is the all of the text actually you can see here. So it has loaded all the txt file one by one, and it has extracted the data, and this is your entire data as you can see. So let me show you. See guys, and this is a document object. Okay, this is a document object. Now we have successfully loaded our data. Now guys, before converting this dataset to the embedding and storing it to my Chroma DB, first of all I need to apply something called text splitter on top of it. Basically I need to convert my entire data as a chunks, because as you can see, this is my complete corpus. Okay, see, this is my complete corpus. If I show you, so if I show you the data, see, this is the complete data. Okay, this is the complete data corpus, but this data set is like very huge. Okay, I can't like you can say directly convert it to vector. Okay, so if I'm converting, so what will happen? Okay, let me explain. So what is the use of this chunks? Okay, so see, so whenever you are using any LLM model, okay, whenever you are using any LLM model, so it has one input size. Okay, it has one input size, as well as it has one output size. Okay, output size. So whenever you are giving something as an input to the LLM, okay, you need to always take care about the input. Okay, so I'll tell you like where you need to check the input size and all. So in this case, let's say I'm using OpenAI LLM. Okay, OpenAI LLM. So OpenAI LLM wise, I'll be using something called GPT 3.5 Turbo. So there is a model you will get from OpenAI called GPT 3.5 Turbo, and it has actually one specific input length. So that input length actually you need to see. So if you want to check the input length, just search like OpenAI models. So this is the link, just open it up. And here you will see all the models are available inside OpenAI. So we have GPT-4, GPT 3.5, GPT based DALL-E, okay, GPT-3 Legacy. So these are the model actually. And here I'm going to use this GPT 3.5 series. So I'll just click here. Now here if you see, the first model is GPT 3.5 Turbo. And this is the description about the model, okay, like what are the things they are doing and all. And this is the max token length, as you can see. So it can take an input around 4,097 tokens, okay, at a time. And this is the training data, okay, like up to September 2021 they have trained the data. Okay, so this is the input length. Okay, but if you check your input here, if I open my data, if you see, this input length actually will be more than this 4,000 token, because here if you see, I have loaded the entire documents. All the articles I have loaded. Okay, so there is a possibility this input size would be more than 4,000 tokens. Okay, and if I'm converting all the corpus as my vector embeddings and I'm storing to the vector database, so it will create issue. Okay, so again during storing it will create issue, and whenever you will be giving this data to your LLM model, again it will be creating issue, and you will also get some memory error and all. Okay, so it's better to split our data as chunks. Okay, now what is chunks? So let me first of all tell you, chunks is nothing but, here I have already written, chunks is a size of the maximum number of the character that a chunks can contain. Okay, and there is another concept called chunks overlap. Okay, so chunks overlap is nothing but this is the number of character that should be overlap between two adjacent chunks. Okay, so let's say, so to explain this one, let's say I will take one text here. So let's say this is my entire corpus. Okay, now first of all I need to convert it to chunks. Okay, chunks means I'll be taking some of the chunk size. Okay, let's say if I am writing chunk size is equal to, let's say, 500. So it will take let's say I'll take a new color. So it will start from here and it will go and it will count like 500 character. Okay, it will count 500 character. So let's say this is this will end here. Okay, this will end here, and this should be one chunks. Okay, this should be one chunks. Okay, so again it will start from here. Again it will count, let's say, 500 word 500 character. and we call it as a token. Okay, so let's say this is the here it will end. So this should be another chunks. Okay, so let's say this is another chunks, this is another chunks. Now again, let's say it will start from here, it will start from here, again it will count, let's say it will end here, this is another chunks. Let's say again it will start from here, and let's say it will end here. Okay, I'm taking it randomly, just try to consider. So this is another chunks, and it will start from here, it will end here. Okay, now how many chunks we have got? So 1 chunks, 2 chunks, 3, 4 and 5. Okay, so here I got 5 chunks. Okay, 5 chunks, 5 chunks of the data. See, now if you count this input length, okay, now it should be less than, it should be less than my 4000. I think what is the number? It should be 4097. Okay, 4097. Okay, now my input, size is less than 4097. Okay, so this is the idea of creating these chunks. Okay, instead of converting my entire corpus to the vector, first of all I need to create as the chunks. Okay, then I need to convert it to vector embedding, then I will be storing, and that embedding I will feed my LLM model. Okay, and there is another concept called chunks overlap. Okay, so what is chunks overlap? So if you set this chunks overlap, let's say I will set this chunks overlap, chunks underscore overlap, let's say I have set as 20. So what it will do, so whenever first of all I will wrap, these are the chunks. Okay, now let's create a new chunks again. So let's say whenever it will create a chunks, let's say it will start from here, and chunk size is 500. So let's say it will end here. Now you have mentioned chunks overlap is equal to 20. Now what it will do, instead of starting from here, it will go back and it will count 20 character. Okay, it will count 20 character. Let's say this is my 20 character. Okay, now it will create the chunks from here. Now again it will count, and let's say your 500 character will end here. So this is my another chunks. Okay, so basically chunks overlap means like how much overlapping you are needed from your previous chunks. Okay, so that is called chunks overlap. So it helps you like to understand your context of the text. Okay, instead of using only chunk size, you can also use chunks overlap, so that it can also got to know like what was the previous context. Okay, whenever it will, let's say, see, I'm giving this chunks by chunks. Let's say this is my chunk 1, the chunk 2 and chunk 3. So okay, so instead of giving directly the chunks, if I'm also mentioning chunks overlap, so what will happen, your LLM model automatically will get to know, okay, so this is the context actually. So this sentence, okay, this sentence and this sentence, so after this sentence actually this sentence is coming. Okay, so that's why this chunk size, this chunks overlaps actually helps us. Okay, this chunks overlaps actually help us to understand the context of the entire story. Okay, so that's why we'll be using these two concepts called chunk size and chunks overlap. Okay, now I think this thing is clear. Now let me show you how to do it using code. So I'll come here. Now here, first of all, you need to import something called recursive character text splitter. Okay, so from LangChain dot text splitter, text underscore splitter, import recursive. So recursive character text splitter. Okay, so this is the class actually we'll be using to convert my entire corpus as a chunks. Okay, now I'll just call this class, and inside that you need to mention two parameters. I think I already explained. One is your chunk underscore size. Okay, chunk size. So let's define as 1000. Okay, I am considering 1000 character as my one chunk. Okay, you can give any number. So it's a hyperparameter tuning. You can set any number here, but I saw like people are starting with 1000 here. Okay, and there is another parameter you will give called chunk underscore overlap. So chunk overlap, I will give, let's say, 200. Okay, so again it's a hyperparameter tuning. Now guys, I have created this object. Now I will save this object. So I'll just create a variable called text splitter. Now guys, finally I will convert my entire corpus to my chunks. So I'll just call this object, and here you need to call split dot split underscore documents, and this is my entire documents. Okay, this is my raw documents. So I'll give it here, and I'll store in a document variable. Okay, or I can store it, I think, in a text variable. I think it should be fine. So let's make it as separate. Now let me execute. It's done. Now if I show you my text, guys, so you will be able to see it has converted to chunks. And how many chunks it has converted, I will also show you. See guys, so if I just go up, so guys, see, this is my first chunks, okay, and it is ending here. Then again it is another chunks, okay, then it is ending here. Then again this is another chunks and it is ending here. And from and if you see, in each chunks actually you have 1000 character, okay, 1000 character. And here if you see the chunks overlap, so if you read this text carefully, so you will see some of the sentence are coming, okay, in these new chunks as well, okay, because we have set this chunks overlap as 200, okay. So see, this is my entire chunks. Now if you want to see the length, like how many chunks it has created, so just print the length. So I'll just read as my text. So it has created 233 chunks, okay, altogether. Now it's fine. Now if you want to see any chunks, specific chunks, you just give the index. Let's say I want to see the number 1 chunks. This is the number 1 chunks, and I can also print number 2. Now we have successfully converted our like corpus to chunks. Now what I will do, I will create my DB object, okay, like vector DB object. So just write the comment here, creating DB object. So as I already told you, Chromadb is nothing but it's a local database. So first of all, you need to create a local like DB here, okay, local DB. So you need to specify the name. So here I already prepared this code. So here you need to first of all create one persist directory, and the name can be anything. So here in this case I'm giving as DB, that means database. And you need to specify the embedding first of all, okay. Like I think you know why we need the embedding, because first of all I need to convert my text to embeddings, okay, that means vector. Then I will store this vector, okay, to my vector database, which is nothing but my Chromadb. So in this case I'm using something called OpenAI embedding. I think you remember, here we imported. So OpenAI embedding, so I'll just call it OpenAI embeddings. And by default, if you execute this code, so let me show you which embeddings model it is using. So it is using something called text embedding ADA model, okay, 002. This is the model. Now you can search also here. So if you check here, so it has this model called text embedding ADA 002. Okay, so this is the model. It has also another version, text ADA 001. Okay. Now we have successfully loaded our embedding model. Now what I need to do, I need to create my vector instance. Okay. I need to like create my vector database instance. So to create it, so this is the code for it. It's a simple code only. So first of all, I have created one variable called vector DB, and here I'm just calling my Chroma. I think you remember we imported Chroma from my LangChain. I'm just calling this Chroma. So inside Chroma, you have one function called from documents. Okay, from documents. Now here you just need to give the data, like you just need to give your text, like you just need to give your chunks, like which chunks actually you want to convert as a vector. So in this case, this is my chunks called text. As you can see, this is my text. I'll just copy the name, and here I'll just name it text. Okay, and it will also take the embedding model. Okay, so this is the embedding model I want to use. So in this case, you can use any embedding model. You just need to import it here. Okay, so here I'm using OpenAI based embedding model, so that's why I have initialized it here. So here I'm giving the embedding model, and here you also need to give the persist directory, like where it will save after, let's say, converting to vectors, where it will save. So it will save inside this DB folder. Okay, so here I'm giving the directory. So these three parameters you just only need to give here. Okay, that's it. And if you're not giving any embedding model inside Chromadb, it will automatically take OpenAI embedding model. Okay, I think they have already written here. If you see here embeddings, so they're automatically, I think, taking some embedding model using OpenAI API key and all. Okay, so they have already mentioned here, like it will automatically load, but it's better practice to mention. Okay, always better practice to mention here. That's it. Now if I execute it, so first of all, what you will do, I'll just remove this directory. Now see, it is converting everything to the vectors. Okay, all the text has been converted to vectors. Now I need to save it to my disk. Okay, now see, it has converted everything to the vector. Now I need to save it to the database. Okay, now this is the code for it. Just write vector db persist and vector db is equal to none. Now if I execute it, now you'll see it will create one db here, local db. Now if I refresh, see guys, db has been created. Now inside that, it has saved all the vector. Now see, it's a binary format, you can't see the vector here, so that is the issue with this local db. But whenever I will be showing you like Pinecone and Waviate, you will able to see the vector, like how it has generated the vector, okay, how it has generated the embedding, everything you can see in the cloud. Okay, you can see all the list of the vector there. Okay, so that was the beauty of this cloud vector database, but again it's a local one. Okay, so that's why it's a binary representation here. So yes guys, we are successfully able to save our vector here. Okay, now let's say you want to load it. So how to load it? So this is the code for it. So here you just need to mention Chroma. Okay, just call the Chroma, and here you just need to mention the directory you have your data. So this is my database db. So here I'm giving the persist directory, which is nothing but db in this case. And here you also need to give the embedding. Okay, so this is the embedding I'm using. Now here I'm giving my persist directory. So in this case it's a db. Okay, now it will automatically load this vector and everything, okay, from this db itself, because it's a binary representation, I already told you. Okay, and as well as I'm also giving my embedding model. Now let me load it. Now I think you remember I told you something called similarity search. Okay, now once we have loaded this vector to my vector database, now you can apply similarity search on top of it. Okay, we call it as retriever. Okay, retriever. So now let's show you the demo of the retriever. So I'll just comment it out, make retriever. Okay, so to retrieve any specific information with respect to the question you are asking, you need to set this parameter called vector as retriever. Okay, vector db. So this is my object vector db as retriever, and this is my retriever object. Now let me execute. Now here I'll just call this retriever object, and here there is a parameter called get retrieve documents. Okay, that means I'm trying to tell my vector database whatever question I'm asking, try to give the similar kinds of you can say data, okay, with respect to the question I'm asking. So here I'll ask one question. Let's say here I have Microsoft articles as well. I think if you see here, I think Microsoft articles is also there. So I can ask one question, just like how much money did Microsoft raise? Okay, so let's say this is my question. Now by default I'll store it in a docs. So by default it will return for a relevant answer. Okay, for relevant answer. If I print it, see, it will return you for similarity answer. Okay, for most similar answer. Okay, like whatever vector are closed, I think I was explaining in the theory. So it is the most relevant and most similar answer. Okay, for most similar answer. So if I show you the length, so you can also set this parameter like how many relevant information you want. See, it is returning me 4. So let's say you only want, let's say, 2 relevant answer. Okay, so in this case you can set this parameter vector db as retrieve, search keyword as k2. Okay, k means like how many answer you want. Okay, so let's say I have given 2. Now if I execute it, okay, done. Now if you want to see like search type, so it's a similarity matrix. I think they're using similarity equation, they're using cosine similarity to calculate this answer. Okay, like the question you are asking, basically it will match with the vector, like what are the closest vector, okay, it will come, so it will return you. So they're considering this similarity cosine similarity matrix, I think there. Okay, so cosine similarity equation, and this parameter will give you like number of return actually it will provide. So it will only provide 2 answer. Okay, 2 answer. Now if I again execute this code, now see guys, now length is 2. Okay, it is only returning 2 answer. Okay, so using this parameter you can set like how many like answer or how many similar answer you want, okay, from your database. Okay, now see guys, it has returned 2 or let's say 4 similar answer, but I want a specific output. Let's say the question I asked, okay, let's say if I print my document, so it's a different kinds of answer actually it will return. Okay, but it's not understandable actually. It's like it is giving like lots of answer and all. Okay, it's giving lots of text, but I want like a relevant answer. Like I just asked like how much money did Microsoft raise, So it should give me like that is the money Microsoft raised. Okay, so it should give me that kinds of answer, but it is returning this kinds of document. Okay, these kinds of chunks. So to get a specific output, okay, from your data, you can take a help from the LLM. So what you can do, let me show you the diagram. So let's say this is my vector DB. Okay, now we have stored our vector embedding here. Vector embedding we have stored here. Okay, now you are giving any kinds of query. Let's say this is your query. So here in this case, let's say you ask like how much money Microsoft raise, right? So this is your question. So it is returning, let's say 4 or let's say 2 output documents. Okay, but this 4 or 2 output documents is not readable. Okay, I am not getting my specific answer. So what I can do, I can integrate LLM model. So let's say I will initialize my large language model here, which is nothing but GPT 3.5 turbo in this case. Okay, turbo. So I'll give this answer to my LLM model. Okay, I'll give this answer to my LLM model, and LLM model will analyze this answer. It will also analyze this query. Okay, it will also analyze this query. With respect to that, it will give me the authentic output. Okay, the correct output, correct meaningful output. Okay, that is the power of LLM. I think you know why it is powerful and all. Okay, because it has trained with huge amount of unstructured data, so it can perform all kinds of tasks. Okay, that's why we will be using LLM, okay, to retrieve our specific answer with respect to the specific question I'm asking. Okay, so this is the idea. So now to do it, actually, first of all, I need to make one chain. Okay, so let me just comment it out. I think you know what is chain in LangChain. Okay, so I'm not going to explain because I think you already learned this chain in LangChain. Okay, why we use chain and all. So first of all, I need to import something called retrieval QA chain. Okay, so I'll just write from LangChain dot chains import retrieval. So whenever you are using vector database, okay, it is returning retrieval output, right? Like related output. So you need to use this retrieval QA. That means retrieval question answering chain. Okay, so it will help you to ask the question, okay, to the data actually you have stored in your DB. Okay, so that's why this chain is required. Retrieval question answering. So I'll import this chain. Now here, first of all, you need to make one chain. So I have already made one chain here. So this is the chain. So I'm just calling retrieval QA chain, and there is a function called from chain type. So here you need to specify the LLM model. So here in this case, I'm using OpenAI LLM model. Okay, so let me show you how it will give you the model. So if you just run it in a new cell, now if you print this LLM, so this is nothing but your GPT 3.5 turbo. Yeah, so it's not giving the name, but if you see the documentation by default, whenever you call OpenAI, so it will give you something called GPT 3.5 turbo. Okay, this model actually, if I GPT 3.5, so this model actually it will return. Okay, so I'll be using this LLM, and here I'm giving this LLM model, and chain type is stuff. Okay, I think you already know what is chain type and all. And retriever, so you need to give the retriever object here. Okay, this is the retriever object. So basically, whatever question you are asking, okay, whatever question you are asking, it will return you from this retriever, right? Because you have given this retriever here. Okay, so that's why you need to give this retriever object here, and you also need to give the return source documents. Okay, return source documents means it will return the source also. Like, see, we have lots of data here. If I show you, we have lots of article here. Okay, now which article it is referring to give the answer. Okay, it will also give you as a reference that article. Okay, so this is the idea of this. Now if I execute, now let's ask one question and print this response. Okay, so here I'm calling my QA chain, and this is the query. Same query I'm asking, how much did Microsoft raise the money. Okay, so this is the query I'm giving my inside my chain, and this is the response of the LLM. Now if I print this, see guys, this is the query. Now it's telling around $10 billion. Okay, raised like this Microsoft, and this is the source document. Okay, but it's not readable. So what you can do actually, you can write one function here process LLM output or process LLM response. So this is the function you can write. So whatever response it will give, it will process only, like it will give it the result, source, and the answer. Okay, now if I execute, now if I call this function here, now I'll just remove this response here. Okay, now I think it should give me the yeah. So now you can see this is the clear output. Now around $10 billion, and these are the source. Actually, it has referred this to file as a source. Now see guys, we are able to successfully store our vector to the vector database, and we are also able to make the query on top of that. And we also saw that like how we can found the similar kinds of you can say output, okay, using this retrieve, okay, using this retrieve option. Okay, so you can ask any different question also. So let's say I will ask another question here. So what is the news about Pando? So there is again another Pando articles you will see inside the data. Now again I'm giving inside my chain, and it is giving the response, and I'm just processing the response. Now see, Pando is a startup that has raised $30 billion in a Series B round, and bringing its total raised. Okay, so this is the complete answer, and this is the source it is giving. Okay, I think I don't need to print this. Yeah, so this is the source. So yes guys, that's how actually you can do it. And one thing I also want to show you, like how to, let's say you want to delete this database, so how to do it. So deleting DB, so it's like very easy. First of all, you can make a zip file, okay, of your existing DB, so that later on if you want to retrieve it, you can retrieve it. Okay, so first of all I'm making it a zip file, then I'll be deleting it. So first of all I'll make a zip file. Now see guys, if I refresh, so first of all it will make a zip file of this DB. Okay, now I'll be deleting. So this is the deleting code, so it will clean up everything. Now if I refresh, now see database has been deleted. Okay, now let's say you want to get your previous DB. Okay, like you had, let's say some specific or let's say important vector there, you want to get back. So what you can do, you can unzip that zip file. Okay, so this is the zip file, you can unzip. Now again your database will come. Now what you need to do, you need to restart the runtime. Okay, so just click here, and there is option called restart the runtime. If you restart the runtime, again you can able to use your DB same wise. Okay, like we already imported our DB right here. So here, that's how you can load your DB again. Okay, so this is the functionality actually Chromadb provides. Okay, if you see the documentation, they have written everything. Even they have also given the starter notebook and all. Okay, so guys, I think as of now you got the entire idea about the Chromadb, like how we can use Chromadb vector database, and how we can connect the large language model, and how we can perform this let's say vector search operation, right? So one thing I just wanted to show you, see, if you click on the integration, see, this Chromadb is having like different integration. That means you can use Chromadb with OpenAI, Google Gemini, Cohere, Hugging Face, okay, Instructor, Hugging Face embedding server, GenAI, RoboFlow, okay, Olama embeddings, everything you can use. Okay, everything you can use with this Chromadb. Now we can see some framework integration, like it can also support LangChain, Llama Index, then BrainTrust, LLM tree, okay, then Streamlit, HighStack, OpenLit. So these are the framework also you can connect. Okay, that means it has actually all the integration. If you are using different framework, different let's say large language model, different platform, everything it can support. Okay, so as of now we saw like how we can use with the help of LangChain. Going forward we'll be also learning how we can use with the help of Llama Index and so on, right? So yes guys, this is all about from this video. In the next video we'll be learning another amazing vector database called Pinecone, and Pinecone is a cloud-based vector database. That means we can store our embeddings in the cloud platform. With that guys, thank you so much for watching this video, and I will see you next time.